A 0.135 molar solution of a weak base has a pOH of 2.77 and we are asked to calculate Kb of this base. So the first thing that we need to do is we need to write our equation for the weak base dissociation. And let's say here they did not give us the formula for the weak base. So I am just going to call it A minus. What is the equation for dissociation? So our base gets together with water and it will produce its conjugate acid, which is HA, so one hydrogen more, and OH minus. A base will make OH minus, and this is just an equation that you can memorize. Whenever a weak base dissociates in water, it produces its conjugate acid and OH minus. This is always the equation for the dissociation of a weak base. The next thing that we're going to do is we will make the ice chart. And in our ice chart, I stands for initial, so we will include any of the initial concentrations given, and we see that there is a 0.135 molar solution of weak base, so our initial concentration of weak base is 0.135 molar. Now, because water is a liquid, it is not going to be a part of the ice chart or of our Kb expression. So we do not have any information about HA and OH minus. This only talked about the weak base. Initially we're starting with weak base, and that means these initially are 0. C stands for change. What side is going to increase and what side is going to decrease? A side that has 0 will always increase because you cannot have a concentration less than 0. So as my weak base is dissociating, it will decrease by some amount that I don't know, x. And the other side, the product side, will increase. E stands for equilibrium, and we will just add the two values here. So this is going to be 0.135 minus x. This is going to be x, and this is going to be x. This is my ice chart. Now let's see what I know. So here they gave me pOH is equal to 2.77, and from pOH we can find the concentration of OH minus. The concentration of OH minus will be 10 to the negative pOH, or 10 to the negative 2.77, and let's go ahead and plug that into our calculator to see what the number is. 10 to the negative 2.77 is equal to 0.001691698. So this is my concentration of OH minus. What is it? Well, if you look at the ice chart, the concentration of OH minus at equilibrium is x. So that means I just found my x. They're asking me to calculate Kb, and that's what I'm going to write out next. K is equilibrium expression, and it will be the concentration of products over the concentration of reactants. So it will be the concentration of HA times the concentration of OH minus over, and again we skip water because liquids and solids are not a part of our equilibrium expressions, over the concentration of A minus. In terms of axis, this is going to be x squared over 0.135 minus x. And we know what our x is. It's this number. So all we have to do now is we have to plug this number in terms of our x, and that's how we will get our Kb. Let's go ahead and do that. So we have this number squared over, then I'm going to put in parentheses 0.135 minus that number. And let's see what my Kb is. So here it says that my Kb is 2.16353 times 10 to the negative 5. Now, if I want to use the correct number of significant figures, I see that the two numbers given that Actually, the pOH given to me, only these I consider significant. So 2 significant figures, only the numbers after the decimal points I consider significant in pOH. So it will be 2. So I need 2 significant figures. 2.2 times 10 to the negative 5 is my answer for the KB.